Welcome to Mythos AI, your source for Cliff's Notes on complex subjects. Join Anna and Phil for yet another engaging conversation.
Welcome back, everyone. Today, we'll be taking a deep dive into the AI business ecosystem.
An incredibly complex and dynamic landscape.
Absolutely. We're going to trace the journey of AI, from the raw materials that make up the hardware.
Right to the software and services driving this technological revolution.
It's easy to think of AI as this purely digital phenomenon.
But it's deeply intertwined with the physical world.
Huh.
And it all starts with the raw materials.
Okay, so let's start there. Where do we even begin?
Well, silicon. Silicon, it's the primary component.
Of those semiconductor wafers?
Exactly. Those wafers that form the heart of AI chips.
Okay, so silicon. And I think most people know that silicon is abundant.
It is.
But what they probably don't realize is how much work goes into it.
Refining it to the ultra-high purity levels that are required for these advanced chips.
Right, it's a really complex and resource-intensive process.
Mm-hmm.
Okay, so silicon, what else?
Well, we can't forget about rare earth elements. Now, they're not directly used in chip fabrication, but they are absolutely crucial for various components found in AI systems. Think high-performance magnets used in cooling systems and electric motors.
So they basically just enhance the performance and efficiency of everything.
Exactly, which makes them essential for this kind of hardware.
And the supply of these rare earth elements is not without its challenges.
You're absolutely right. China holds a dominant position in the global supply chain for rare earth elements.
Mm-hmm.
They control a significant portion of both mining and processing capacity. And this obviously has some strategic implications for the industry as a whole.
For sure. Anyone looking to develop or expand their AI capabilities is inherently reliant on that supply chain.
Yeah.
I guess the next question is, are there any companies that are trying to address that?
Yeah, absolutely. So in the United States, for example, you have MP Materials. They're working to diversify that rare earth element supply chain.
It's interesting how geopolitical factors always seem to intersect with technological innovation.
Mm-hmm.
It's not just about developing the technology. It's also about making sure you can access the essential materials to actually produce it.
Yeah.
So we've got silicon, we've got rare earth elements. What other materials are we talking about here?
Well, lithium and cobalt are also really important, specifically for the batteries powering data centers and mobile AI devices.
Okay, so that makes sense. What companies are major players when it comes to lithium and cobalt?
Well, there are companies like Glencore and Albemarle.
Okay, so we've talked about the raw materials. Let's move on to the next stage, which is the chip architecture design. What's going on in this stage?
Well, it's a lot like creating the blueprint for AI hardware.
Okay.
Think of it as determining how to arrange transistors and connections on a chip
Mm-hmm.
to achieve that optimal performance for all those AI computations.
Okay, so it sounds like there's this delicate balancing act going on between performance and efficiency and cost. What are some of the key players in this space?
You've got companies like ARM, NVIDIA, Intel, AMD. They're all major players in this.
Let's start with ARM. What are they known for?
Well, they're really known for energy-efficient designs,
Okay.
which are super important for mobile AI applications where power consumption is always a key consideration. And they utilize what's called a reduced instruction set computing architecture.
Okay, what's that?
So it's often called RISC, and basically it means that those processors are designed to execute a smaller set of instructions more efficiently.
So it's kind of like you're trading off, you're limiting the number of instructions the chip can handle, but by doing that, you can optimize it to process those specific instructions much faster and more efficiently.
That's exactly right.
Okay, that's interesting. What about NVIDIA? Because I know they are a really big player in this.
Oh, they are huge. NVIDIA is the dominant force when it comes to graphic processing units or GPUs, and they've really become crucial for AI training. They focus on parallel processing, so that allows GPUs to handle just massive numbers of calculations simultaneously.
That makes sense. And obviously, their CUDA platform plays a role here, right?
Yeah, absolutely. CUDA is it's a parallel computing platform and programming model is developed by NVIDIA. And it really enables developers to leverage that parallel processing power of GPUs. And they use it for general purpose computing, including AI and machine learning.
So it's become the industry standard,
Oh, yeah.
which has given them a significant advantage. What about the more traditional players like Intel and AMD? How are they responding to this rise in AI?
Well, both Intel and AMD are traditionally known for their central processing units or CPUs, but they've also recognized the importance of the AI chip market and they've developed their own offerings. So Intel's Xeon processors, they're widely used in servers, and their acquisition of Habana Labs,
Which specializes in AI processors.
yeah, it really strengthened their position in this space.
So it's not just about GPUs anymore,
Mm.
right? CPUs are still very much relevant, especially for certain specific AI workloads.
Yeah, precisely. And then you have AMD with their Radeon and Instinct series of GPUs, and they're really providing strong competition to NVIDIA in the AI hardware market.
Yeah.
Their focus is on delivering high-performance computing solutions for a whole range of applications, including AI and machine learning.
Okay, so we've got Intel, AMD, and NVIDIA. What about Google? Because they're doing their own custom designed chips too, right?
Yeah, they've developed their own tensor processing units, or TPUs,
Yeah.
and these are specifically optimized for machine learning tasks. They're used internally for a lot of their own AI applications,
That makes sense.
but they are also offered to businesses and researchers through Google Cloud.
So we've got all these big players. It sounds like this market is incredibly competitive.
Oh, it is.
With each player kind of vying for their piece of the pie, are there any other trends or companies that we should know about in this space?
Well, one interesting development is the emergence of RISC-V.
Okay.
It's an open source alternative to proprietary chip architecture.
So it's basically allowing companies to design and manufacture chips without paying licensing fees.
Yeah, exactly. So it's really appealing, especially to startups and even nations.
Looking for technological independence.
Yeah.
That's fascinating. So it's not just these huge companies that are dominating. There's room for these smaller companies to innovate as well. What about the tools and technologies that are used in this design process?
Right. Well, behind the scenes, you have companies like Cadence and Synopsys, and they're playing a critical role in providing electronic design automation, or EDA tools, which are essential for designing and developing these complex chips.
Okay, and what exactly do those tools do?
Well, they enable engineers to design, simulate, and verify chip designs before sending them off to be manufactured.
So it's a highly specialized field. We've gone from these raw materials, and now we're designing the architecture of these chips. What's the next step?
Well, the next step is really bringing those designs to life. And that happens through chip manufacturing.
Okay.
And this is where companies like ASML and TSMC enter the picture.
So now we're talking about actually turning those blueprints into physical chips.
Exactly.
That sounds incredibly complex.
It is. It's a very complex and highly specialized process that involves transforming silicon wafers into functional chips.
Okay.
And ASML, this Dutch company, plays a really critical role. They're the sole provider of extreme ultraviolet lithography machines,
Okay.
which are essential for creating those really tiny transistors.
That are on today's most advanced chips.
Yeah.
So without ASML, basically the entire semiconductor industry, and by extension the AI industry, would grind to a halt.
Pretty much, yeah. Their machines are a bottleneck in the process.
Wow.
And their technology is vital to meet the demands of Moore's law.
Which states that the number of transistors on a microchip doubles roughly every 2 years.
Yeah.
Wow. So ASML makes the machines that are allowing chip manufacturing at this scale. What about the actual manufacturing itself?
Right. Well, that's where TSMC, the Taiwan Semiconductor Manufacturing Company, comes in.
Okay.
They are the world leader in semiconductor manufacturing. They're responsible for producing chips for a lot of the tech giants that we've mentioned, Apple, NVIDIA, AMD. And their ability to manufacture these incredibly small nodes, like 3 nanometers and 5 nanometers, is just crucial for enabling that high performance and power efficiency that's required for AI applications.
And just to put that in perspective, a nanometer is 1/1000th of a meter.
Yeah, they're really, really small.
That's mind-bogglingly small. So they're basically etching these intricate circuits onto these tiny wafers. Are there any other players in chip manufacturing?
Well, TSMC is really the dominant force, but Samsung, the South Korean tech giant, is also a major player. They're competing directly with TSMC. And then Intel, as we discussed, is moving into the foundry business with Intel Foundry Services.
Right.
So they're trying to leverage their expertise in chip design and manufacturing to offer foundry services. And really, they're aiming to diversify the market and provide an alternative to these other two companies,
Hmm.
and they're focusing on advanced packaging technologies.
Okay.
So that's combining multiple chips or components into a single package.
Okay, so it's not just about making individual chips anymore. It's finding innovative ways to package those together for specific applications.
Exactly.
And then we have Global Foundries, another major player.
Yeah, and they focus on more specialized chips for, specific industries, specific applications.
So they're catering to those niche markets.
Yeah.
Okay, so we've covered ASML, providing the essential machines, TSMC, which dominates manufacturing, Samsung, head-to-head with TSMC, Intel entering the market, Global Foundries with the niche markets. It's amazing to see all these companies working together to manufacture these chips. Now, what about China? Because we talked about their dominance with the rare earth elements. Are they making any strides in chip manufacturing?
Yeah, they are actually investing heavily in developing their domestic semiconductor industry.
Hmm.
And the Semiconductor Manufacturing International Corporation, or SMIC, is their leading chip manufacturer. And they are making some progress in advancing their technological capabilities.
So China's really aiming to become more self-sufficient.
Yeah.
So what happens once these chips are manufactured? What's that next stage?
Well, then comes the assembly and integration stage. This is where the manufactured chips are incorporated into larger systems, like servers or consumer devices.
Okay.
And this is where companies like Foxconn, Pegatron, and ASE Technology Holding come in.
Okay, let's talk about Foxconn first, because I think most people know that name.
Yeah, they're a well-known name in the electronics industry.
Mhm.
They are the world's largest contract electronics manufacturer.
I think most people probably know them for assembling iPhones for Apple.
Yeah, but they also play a crucial role in integrating semiconductors into a whole range of devices.
Like servers, workstations, other AI hardware.
Yeah, pretty much. So
Yeah.
they're taking those chips and integrating them into the final products?
Exactly. And they're not the only one. We've got Pegatron and Flextronics.
Yeah, they're also big players in this electronics assembly market.
Yeah.
Pegatron often collaborates with Foxconn on those larger scale manufacturing projects.
Okay.
And Flextronics tends to focus on providing integrated solutions for more specialized technology products.
So it's just this complex network of companies, each with their own expertise.
Yeah.
And then there's ASE Technology Holding.
Yeah. They are a leader in semiconductor packaging. So that's the process of protecting and connecting the delicate silicon chip to the larger system.
And it sounds like that would be a pretty crucial step.
Oh, it is.
What are some of the challenges involved in that?
Well, as chips are becoming more powerful and more compact, the packaging technology has to keep pace.
Mm-hmm.
So they're developing really advanced packaging solutions, things like chip stacking, which involves vertically stacking multiple chips on top of each other, almost like building a high-rise building.
Wow, that's a great analogy. So we've moved from raw materials to chips to assembling those chips into larger systems. What's the next step in building out this ecosystem?
Well, now we need to talk about the infrastructure that actually houses these AI workloads.
Okay.
So servers and data centers.
Mm-hmm.
These are the powerhouses behind AI, providing all that computational muscle that's needed for both training and executing the models.
So let's start with servers. What are the key companies and technologies in that space?
Well, when it comes to servers, companies like Dell Technologies, Hewlett-Packard Enterprise, or HPE, and Supermicro are major players.
Okay.
Their servers are designed to handle those demanding workloads of AI, and they offer a balance of processing power, memory, storage, and networking capabilities.
Can you give some specific examples of what they're offering?
Yeah, so Dell's PowerEdge series, it's really widely used in data centers for a variety of applications, including AI processing,
Okay.
and they offer a range of servers tailored to different needs and different budgets.
Okay. And HPE.
HPE's ProLiant servers, they're designed for scalability and performance, making them really suitable for AI workloads that require those significant computing resources.
And you mentioned Supermicro before. What do they do?
Yeah, they focus specifically on high-performance computing,
Okay.
and they offer servers that are specifically optimized for AI and machine learning tasks. So their servers often feature a higher density of GPUs and other specialized hardware to accelerate those workloads.
And we talked about GPUs from NVIDIA and AMD, but NVIDIA also has their DGX systems. How do those fit in?
Yeah, so their DGX systems are purpose-built AI supercomputers.
Wow.
They combine multiple high-end NVIDIA GPUs with optimized software and networking to deliver exceptional performance for AI training and development.
So you're saying if a company is really serious about their AI research and development, a DGX system is what they would invest in?
Absolutely.
Okay, so we've covered servers, which are those individual units that house the computing power. Now let's talk about data centers, which are those vast facilities that house the servers. Who are the major players when it comes to data centers, especially when we're talking about AI?
Right. Well, cloud giants like Amazon Web Services or AWS, Microsoft Azure, and Google Cloud are all crucial players in the data center space, particularly when it comes to AI.
Mhm.
They offer a range of cloud computing services that are tailored for AI workloads, providing access to vast computational resources, storage, and those specialized AI services on demand.
Okay, let's talk about each of these. Let's start with AWS.
Sure. Okay, yeah. So AWS offers their Elastic Compute Cloud or EC2 instances,
Okay.
and those are basically virtual servers that you can rent on demand.
Okay.
And they offer various EC2 instances that are optimized for AI. They're powered by NVIDIA GPUs and their own custom-designed AWS Inferentia chips, which are designed to accelerate machine learning inference.
So if you're a company and you need to train or deploy an AI model, you can essentially just rent the computing power from AWS without having to actually invest in all that expensive hardware yourself.
Yeah, it's much more flexible. It's a much more scalable approach to accessing these resources.
Okay, what about Microsoft Azure?
Right. So they offer services like Azure Machine Learning,
Okay.
which provides a cloud-based platform for building, training, and deploying machine learning models.
Okay.
And Azure Databricks, which is a platform for large-scale data engineering and collaborative data science.
So they're providing the tools and the infrastructure for companies to manage their entire AI workflow all in the cloud.
Yeah, exactly.
Okay. And I'm assuming Google Cloud leverages its own TPU technology.
Yeah, so Google Cloud offers access to their TPUs, which, as we talked about, are specifically designed for accelerating those machine learning workloads. And they also have their Vertex AI platform, which provides this unified environment for building, deploying, and managing AI models.
So we've got Amazon with their EC2 instances, Microsoft Azure with their Azure Machine Learning and Databricks, and Google Cloud with their TPUs and Vertex AI. It sounds like these three are really dominating the AI infrastructure landscape.
They're definitely major players, but it's not just about the cloud.
Oh.
Companies like Equinix and Digital Realty, they offer what are called co-location services.
Right.
And these are essential for companies that maybe want to host their own hardware rather than relying solely on the cloud.
So I'm guessing if a company has specific security or compliance requirements that prevent them from using the cloud, co-location is an option for them.
Yeah, exactly. So co-location providers, they offer the physical space, power, cooling, security, that's necessary to house servers and all that other IT equipment.
So it's kind of like a specialized data center that's renting out space to other companies.
Yeah, you could think of it that way.
It's interesting to see how all these companies are accommodating the different needs of all these different businesses.
Yeah.
And while we're talking about data centers, even though they're not traditional data center providers, companies like Meta and Apple are also operating these massive data centers, right, to support their own operations.
Yeah. And they really contribute to server hardware innovation.
So we've gone from raw materials to chips to servers to data centers, which kind of brings us to this crucial aspect of AI data itself.
Yeah.
And data is often referred to as the fuel that powers AI.
It is.
Without vast amounts of data to learn from, algorithms just wouldn't be able to do what they do. And the companies that are involved in data storage, processing, and labeling really play a crucial role in this entire ecosystem.
Yeah, they do.
Let's start with data storage. I mean, we're talking about massive amounts of data. What are some of the companies and technologies that are involved in storing and managing this?
Right. So you have companies like Cloudera and Snowflake.
Okay.
They are leading providers of these big data storage and analytics solutions.
Okay, and what are these platforms actually doing?
So imagine, you're a large online retailer. You have millions of customers, billions of data points, information on customer behavior, purchase history, browsing patterns. Managing all of that data and actually trying to make sense of it would be really difficult without the right tools. So companies like Cloudera and Snowflake,
Right.
they provide the infrastructure and the tools to store that data securely, to process it efficiently, and then extract those meaningful insights from it.
So it's kind of the foundation for data-driven decision-making.
Yeah.
Okay, that makes sense. What about data processing? Because again, these are huge data sets that we're talking about. How do you even process and analyze those?
Right. Well, that's where data processing tools like Apache Hadoop and Spark come in.
Okay.
These are open source frameworks that are specifically designed to handle large-scale data processing across clusters of computers.
Okay.
And they break down large data sets into smaller chunks, and then they distribute them across multiple nodes for parallel processing, and then they aggregate the results.
Yeah.
So it makes it possible to analyze these massive data sets that you wouldn't be able to process on just a single machine.
So it's all about distributing the workload and processing the data in parallel to speed up the entire process.
Yeah, exactly. It's kind of like, having a team of people work together to solve a really complex problem instead of just one person trying to do it all themselves.
That's a good analogy. So we've covered data storage, we've covered data processing. What about data labeling?
Right.
Because we talked about how important data is, but how does data labeling fit into the picture?
Right. So data labeling is a critical step in supervised learning,
Okay.
which is a type of machine learning where algorithms learn from those labeled examples. So imagine you're trying to train an AI model to recognize different types of fruit.
Okay.
You would need to provide that algorithm with a data set of images of fruits, where each image is labeled with the correct type.
So you're basically just teaching the algorithm by example.
Exactly.
Okay, so who are the key players in this data labeling space?
You've got companies like Scale AI, Appen, Samasource.
Okay.
They all specialize in this, and they provide these really high-quality labeled data sets for all these AI applications.
Like image recognition, natural language processing, speech recognition.
Yeah, all that stuff.
So it's not just about collecting the data. It's about making sure the data is properly labeled.
And structured for AI training.
Exactly.
Yeah.
And the quality of the data is just as important as the quantity of data.
Oh, absolutely. Garbage in, garbage out.
Right. So we've covered these foundational layers of the AI business ecosystem. We've got the raw materials, chip architecture and manufacturing, assembly and integration, servers, data centers, the role of data.
Mm-hmm.
Now let's move on to the companies that are developing the brains behind it all.
Right.
The AI models and the software.
Yeah, this is where it gets really interesting. This is where we see all of the hardware and the data and that algorithmic innovation come together to create the AI applications that are really transforming the world around us.
So who are some of these major players in the space?
One of the most prominent names is OpenAI.
Okay.
They're known for developing those groundbreaking models like GPT-3, GPT-4, and DALL-E.
And those names are certainly making waves in the tech world. Why are they so significant?
Well, GPT-3 and GPT-4 are large language models.
LLMs.
Yeah, and they've demonstrated impressive capabilities in natural language understanding and generation. They can generate human-quality text, translate languages, write different kinds of creative content, and they can even answer your questions, even if they're open-ended, challenging, or strange.
So they're pushing the boundaries of what's possible when it comes to AI and language.
Yeah. And then there's DALL-E, which is a generative model that can create really realistic images and art from a description in natural language.
So you could describe an image to DALL-E and it will generate it for you.
That's it.
That's incredible. What's behind OpenAI's success? They seem to be at the forefront of all this.
Well, one thing is their partnership with Microsoft.
Okay.
And that gives them access to all that computational power of Microsoft Azure, which is essential for training these massive AI models.
So it's not just about having brilliant minds. It's about having the resources to support that research and development.
Yeah, absolutely. AI research is a resource-intensive endeavor.
Okay. So we've talked about OpenAI. What about some of the other major players?
Well, you've got Google DeepMind.
Okay.
They're known for their work in reinforcement learning. So that's where an AI agent learns through trial and error by interacting with an environment.
Okay.
Yeah.
What are some examples of their work in that space?
Well, their AlphaGo program, it made headlines a few years ago when it defeated Lee Sedol, who was a world champion Go player.
Okay.
And that was a significant milestone in AI. Go is a very complex board game that was once thought to be too difficult for AI to master.
So DeepMind basically proved that AI could surpass human capabilities.
Yeah.
In a game that was considered too complex.
Yeah, exactly. And then they also have their AlphaFold program, which is a protein structure prediction model, and that has achieved remarkable accuracy in predicting the 3D structure of proteins.
Which is obviously crucial for understanding biological processes and developing new drugs and therapies. So their work is potentially going to revolutionize fields like drug discovery and disease research.
Yeah, it really highlights the interdisciplinary nature of AI. It's not just about computer science, but it's about leveraging AI to solve these complex problems across various domains.
Okay, that's really interesting. What about Meta?
Yeah, so Meta AI is also a significant player in the research landscape.
Okay.
And they are known for developing models like Llama, their large language model, which competes directly with OpenAI's GPT models,
Okay.
and PyTorch, which is a widely used open source machine learning framework.
So they're both developing AI models and giving others the tools to do it too.
Yeah, exactly. And PyTorch has become super popular in the research community for its flexibility and ease of use.
Okay.
So it's really well suited for prototyping and experimentation.
And we can't forget about Microsoft.
No.
They're not just providing the resources through Azure, they're also deeply involved in the research and development themselves, right?
Yeah, absolutely. They're integrating AI into their core products, things like Office 365 and Azure Cognitive Services. They offer this whole suite of AI tools for vision, speech, language, and knowledge, making AI more accessible to businesses and developers.
So they're basically advancing the research while also making it available to everyone else.
Yeah, that's a good way to put it.
So we've talked about OpenAI, Google DeepMind, Meta AI, and Microsoft. Are there any other companies that are doing groundbreaking work in AI?
Well, there's Anthropic. They're focusing on building reliable, interpretable, and steerable AI systems. They really emphasize AI safety.
Okay.
So that means ensuring that AI systems align with human values and don't pose a threat as they become more powerful.
So it's not just about developing powerful AI, it's about developing it responsibly.
Exactly.
Okay. That's something we should probably do a whole other deep dive on.
Yeah.
What about globally? We've been talking about American companies. Are there any other major players in other parts of the world?
Yeah, China's a major player in AI.
Yeah.
Companies like Baidu, Tencent, and Alibaba Cloud are all investing heavily.
Okay. Can you tell us more about each of those?
Yeah, so Baidu is often referred to as the Google of China. And they're really involved in AI research, specifically in areas like natural language processing, autonomous driving, and deep learning. They have their own deep learning platform called Paddle. It's essentially China's answer to TensorFlow and PyTorch.
So they're trying to build their own AI ecosystem within their own country.
Yeah, they're facing some competition from those American companies,
Of course.
but they're also trying to leverage their own strengths.
Okay. What about Tencent?
Yeah, they're known for their social media platforms, things like WeChat and QQ. And they're leveraging their massive user base and data to develop AI-powered services in areas like gaming, entertainment, and advertising.
So they're using AI to enhance their businesses that they already have.
Exactly.
Okay. And then there's Alibaba Cloud.
Right.
So they're essentially China's answer to AWS.
Yeah.
Okay.
They provide a wide range of cloud computing services, including AI platforms and tools.
Okay. So we've talked about the companies developing these models and the software. What about the frameworks and tools that underpin AI development?
Yeah, so AI development relies heavily on a variety of frameworks and tools. Think of them as the building blocks that AI developers use to create those AI applications.
Okay. What are some of the key players when it comes to AI frameworks and tools?
Well, you've got TensorFlow, which is developed by Google, and it's one of the most popular open source machine learning frameworks.
Okay.
It provides a really comprehensive set of tools for building and deploying machine learning models,
Okay.
and it's used by both researchers and developers.
And so they're really versatile framework.
Yeah.
That can be used for all sorts of things.
Yeah, and because it's open source, it benefits from a large and active community of developers.
That makes sense. What about PyTorch? Because we talked about that before with Meta.
What's that?
Right, PyTorch. Another popular open source machine learning framework developed by Meta. It's known for its dynamic computation graph, which allows for greater flexibility in model building and debugging. And it's really easy to use, which makes it popular with researchers.
Okay, so it's really suited for research tasks where that experimentation is really key.
Yeah, that's right. And then there's JAX, also developed by Google, which is designed for high-performance numerical computing, and it's becoming really popular in the AI community, particularly for its use in things like reinforcement learning and deep learning.
So it sounds like this AI framework landscape is pretty diverse,
It is.
with all these different frameworks that offer different strengths.
Exactly.
And choosing which one to use really depends on the specific needs of the project and what the developers are familiar with.
And the ecosystem of tools and libraries that are available for that specific framework.
Okay, so beyond those frameworks, what other tools are commonly used? Well, IDEs. So integrated development environments like Jupyter Notebook. They're popular among data scientists and AI developers.
Mm-hmm.
And Jupyter Notebook provides a web-based interactive environment for writing and running code, visualizing data, and documenting the development process.
So it basically just facilitates the entire AI development workflow.
Yeah.
From exploration to deployment.
Exactly. And then there are cloud-based environments provided by those big companies we talked about, AWS, Azure, Google Cloud.
Mm-hmm.
And they offer access to powerful computing resources, pre-installed libraries, collaborative tools.
Okay.
So it really allows the developers to focus on building and deploying the models without having to worry about managing all of that underlying infrastructure.
So making AI development more accessible.
Exactly.
And we can't forget about open source communities
No, we can't.
because they play a huge role in driving innovation.
They do. Platforms like Hugging Face, for instance, have become these central hubs for the AI community to share pre-trained models, data sets, and code.
So instead of starting from scratch,
Yeah.
you can leverage existing models.
And it really accelerates the development process and fosters collaboration.
Exactly. So we've covered everything from raw materials to the companies that are actually developing these models.
Right.
Yeah, I want to talk about a trend that's bringing AI closer to the edge.
Mm-hmm.
Edge computing.
Yeah, edge computing, an interesting development. It involves processing data and running AI algorithms locally on devices,
Okay.
rather than relying on those centralized cloud servers.
So instead of sending the data to the cloud, you're bringing the processing power to where the data is generated.
Exactly.
What are the benefits of that?
Well, edge computing offers several advantages: reduced latency, enhanced privacy, and greater resilience.
Let's talk about each of those.
Yeah.
Let's start with reduced latency.
Okay, so in traditional cloud computing models, that data has to travel from the device to the cloud, get processed, and then the results have to be sent back to the device.
Mm-hmm.
And that back and forth can introduce latency.
Which is the delay between the request and the response.
Yeah. And for time-sensitive applications,
Right.
that latency can be a problem. With edge computing, data can be processed locally on the device or on a nearby edge server.
So it significantly reduces the distance that data has to travel.
Yeah, exactly.
Okay, what about enhanced privacy?
Right. So sensitive data can be processed locally on the device,
Mm-hmm.
which means it doesn't have to be sent to the cloud. And that's super important for applications that involve really personal or confidential data.
Like in healthcare or finance?
Yeah, things like that.
So by keeping that data local, you're minimizing the risks of breaches and privacy violations during transmission.
Exactly.
And the last benefit you mentioned was greater resilience.
Right. So in traditional models, if the connection to the cloud is disrupted,
Mm-hmm.
the application or service might become unavailable.
So you're reliant on a stable connection.
Exactly. But with edge computing, because the processing is done locally, the application can still function even if there's a disruption. Mhm.
So it's a much more reliable solution.
Yeah.
Okay, so who are some of the key players in this space?
Well, you've got companies like NVIDIA, Intel, and Qualcomm. They're all leading providers of hardware and software solutions for edge computing.
Okay, what are some examples of the things they're offering?
Well, NVIDIA offers its Jetson platform, which is a series of AI computing modules specifically designed for edge applications.
Okay.
And these modules combine those powerful GPUs with CPUs and other components
Mm-hmm.
to provide the computational power to run those algorithms locally.
So basically it's like a mini supercomputer on a chip.
You could think of it that way. And then you have Intel. They provide their Movidius processors.
Okay.
And those are specifically designed for running deep neural networks on edge devices.
Okay.
And they're known for their low power consumption and high performance,
Okay.
which makes them really suitable for those battery-powered devices, things like drones and cameras.
So depending on what you're trying to do and what the power constraints are, there are different hardware options available.
Yeah, exactly.
Okay. And what about Qualcomm?
Well, they're a leader in mobile processors, and they're incorporating AI capabilities into their Snapdragon chips,
Okay.
which power a lot of smartphones and other mobile devices.
Okay.
So that means your smartphone can do things like image recognition, voice processing, language translation locally on the device without relying on the cloud.
So edge computing isn't just about specialized devices. It's bringing AI capabilities to the things we use every day.
Exactly. It's about making AI more ubiquitous
Okay.
and enabling new possibilities across a wide range of applications.
It's fascinating to see how AI is permeating every layer of the technology stack, from the cloud to the edge. But as AI becomes more powerful and pervasive,
Mm-hmm.
it's essential to address the ethical considerations and ensure that it's being developed and deployed responsibly.
Yeah, absolutely. AI ethics and governance are crucial. As we're delegating more and more decision-making power to these AI systems, we really need to establish those clear guidelines and regulations to mitigate potential risks and ensure that AI is being used for good.
What are some of the key ethical challenges that we need to address?
Well, one of the most pressing concerns is bias in AI systems.
Okay.
AI algorithms are trained on data.
Mm-hmm.
And if that data reflects existing biases in society,
Right.
those AI systems are just going to perpetuate and amplify those biases.
Can you give some examples of how this might manifest itself?
Well, imagine an AI system that's used for loan approvals,
Okay.
and it's trained on historical data that contains biases against certain demographic groups. So that system might learn those biases and deny loans to individuals from those groups, even if they're qualified.
So it's not that the system itself is biased, it's that it's inheriting those biases from the data.
Yeah, that's right. And that's why it's so important to ensure that the data used to train these systems is representative and free from bias.
What are some of the steps that are being taken to address that bias?
Well, more and more organizations are focusing on implementing fairness algorithms. And they're trying to diversify data sets to make sure those systems are trained on data that's more representative of the population as a whole. There's also growing awareness of the importance of having diverse teams developing these AI systems.
To bring in those different perspectives.
Exactly.
Okay, so beyond bias, what other ethical considerations are relevant?
Well, transparency is really important. It's crucial that we understand how these systems make decisions.
Right, but they can be really complex.
They can. They're often described as black boxes because it can be really difficult to understand how they arrive at their outputs. However, there is a growing movement toward developing more transparent and interpretable systems.
Oh, okay.
And this allows for greater accountability and helps to build trust.
Okay, and what about accountability? If an AI system makes a mistake, who is responsible?
That's a big question.
Yeah.
And it involves developing ethical frameworks and regulations that address issues like liability and redress. We need to establish clear lines of responsibility and make sure that there are mechanisms in place to address any of those negative consequences that might arise.
So it sounds like we're still figuring all of this out.
Oh, we are. AI ethics is a rapidly evolving field. We're still working out the best ways to ensure that AI is developed and used responsibly.
Okay, so we've covered a lot today, from raw materials to AI algorithms.
Yeah.
Now I want to shift our focus to the economic impact of this revolution. How is this ecosystem influencing industries and creating jobs and reshaping the global economic landscape?
Well, the adoption of AI is leading to some major disruptions across a lot of different sectors.
Okay.
Automation, which is driven by AI, is transforming industries like manufacturing, logistics, customer service, and that leads to increased efficiency and productivity.
So essentially AI is automating tasks that were previously done by humans.
Yeah. So in manufacturing, you have AI-powered robots performing things like welding, painting, assembly, which were traditionally done by humans. In logistics, AI is optimizing delivery routes and managing warehouse operations.
So AI is making these industries more efficient.
Yeah, much more efficient and more competitive. And by automating those tasks, AI is freeing up humans to focus on more creative and strategic work.
Okay, but this automation also raises concerns about job displacement.
Yeah, absolutely. It's a valid concern. As systems become more capable, they are taking over tasks that were previously performed by humans. And that is leading to job losses in certain sectors.
Especially for those jobs that involve those really repetitive tasks.
Yeah,
So it's a double-edged sword. We're getting these gains in efficiency, but we're also losing jobs.
it is. It's complex. It has both positive and negative implications.
So what can be done to address those job displacements?
Well, one approach is to invest in those training and education programs. Equip workers with the skills that they need to thrive. There's growing demand for professionals with expertise in AI, data science, machine learning. So by providing those skills,
Right.
we can help them transition into new roles.
Okay, so it's about adapting and acquiring those in-demand skills.
Exactly. It's also important for governments and businesses to work together to create policies and initiatives that support those workers who are being affected by automation.
So that could be things like financial assistance, job retraining programs.
Yeah, and supporting those who want to start their own businesses.
Okay, so it sounds like it's going to take a multi-pronged approach.
Yeah.
Okay, so we've talked about job displacement, but what about job creation? Is AI creating jobs?
It is. While some jobs are being displaced, AI is also creating new opportunities. The development and deployment and maintenance of these systems require a skilled workforce.
So what are some of those new job roles that are emerging?
Well, we're seeing a huge demand for AI engineers, data scientists, machine learning engineers, AI ethicists.
Okay, can you talk about each of those roles and what they do?
Okay, so AI engineers, they're responsible for designing, developing, and deploying AI systems. They need a strong understanding of AI algorithms, machine learning techniques, software engineering principles.
So they're basically like the architects and the builders of the AI systems.
That's a good way to put it.
Yeah.
And then data scientists, they are responsible for analyzing and interpreting those large data sets, extracting those meaningful insights to train and improve those models.
So they're the ones who are making sense of the
Yes.
data.
Machine learning engineers, they focus specifically on building and deploying those machine learning models.
Okay.
And they need expertise in things like data preprocessing, feature engineering, model selection, model evaluation.
And then AI ethicists.
Yeah, they're becoming super important as we grapple with the ethical implications. They help organizations develop and implement ethical guidelines, ensuring that those systems are used responsibly and fairly.
So while AI is automating some jobs, it's creating new ones that require those specialized skills.
Yeah. It's a really dynamic landscape. The nature of work is changing, so individuals really need to adapt.
Exactly. And the impact extends beyond just job creation and displacement. It's fostering innovation and driving economic growth.
Absolutely. So AI solutions are being developed across all different industries, leading to new products and services, improved efficiency, and increased competitiveness.
Can you give us some examples of how AI is driving innovation in these different industries?
Sure. So in healthcare, AI is being used to develop new diagnostic tools, personalize treatment plans, and even accelerate drug discovery. For example, AI-powered imaging systems can help radiologists detect tumors earlier, more accurately, which leads to better patient outcomes.
So it's augmenting human capabilities,
Yeah.
leading to more effective healthcare delivery.
Exactly. And in finance, AI is detecting fraudulent transactions, assessing credit risk, providing personalized financial advice.
So it's about making financial services more secure and efficient.
Yeah. And in transportation, AI is powering the development of self-driving cars, optimizing traffic flow, improving the efficiency of logistics and supply chain management.
So it's going to change how we move people and goods.
Yeah, for sure.
Yeah.
And in energy, AI is optimizing energy consumption, predicting equipment failures, and managing those renewable energy resources.
So AI is having this huge impact across all these industries.
It really is. It's no longer a futuristic concept. It's here, and it's changing how we live and work.
Right. And this revolution is still in its early stages.
It is.
So as technology advances and becomes more accessible, its impact will only grow.
Yeah, we're still in the early innings. The next few years are going to bring even more rapid advancements and disruptions. So governments and businesses and individuals, they're all going to have to adapt.
It's a call to action for all of us to be proactive
It is.
in shaping this future of AI, making sure it's used ethically and responsibly.
Absolutely. And it's important to consider the broader societal implications. AI is becoming more and more integrated into our lives, and that raises a lot of questions about the future of work and the nature of human intelligence.
Okay, so let's talk about those. Let's start with the future of work. We already touched upon the potential for job displacement and the need for workers to adapt and learn new skills. But what does the future of work actually look like in an AI-driven world?
Well, it's likely that we'll see a shift to more human-centered jobs. Jobs that require things like creativity and critical thinking, emotional intelligence, things that AI, at least for now, can't really replicate.
So you're saying AI will handle the routine work and humans can focus on things that require those uniquely human skills.
Exactly. And this could lead to more fulfilling and meaningful work for humans as they're able to focus on things they're good at and that they enjoy.
But this raises questions about how we prepare people for that transition.
Yeah.
How do we ensure that people have the skills they need?
Right. Well, it requires a multi-pronged approach. Investments in education, training programs, support for lifelong learning. We really need to give people the skills to adapt.
So it's not just about learning specific technical skills.
Right.
It's about being adaptable.
Yeah, that ability to learn, unlearn, and relearn is going to be so important.
Okay. So beyond the future of work, AI also raises those questions about human intelligence. As AI systems are able to do things that we once thought only humans could do, it really begs the question, what does it mean to be intelligent?
Yeah, it really does challenge how we understand intelligence. It makes us rethink what makes humans unique. And, some argue that AI will eventually surpass human intelligence,
Okay.
leading to that singularity where machines are more intelligent than us.
That's a little unsettling.
It is. But others believe that AI will actually augment human intelligence
Okay.
and allow us to solve even more complex problems, things that we wouldn't be able to achieve without AI.
So rather than replacing us, it's going to complement us.
Yeah, exactly. And it's really an open question. We don't really know how this is going to play out.
Right. And of course, we can't talk about AI without talking about the ethical considerations. We talk about bias, the need for transparency, accountability, and using AI for good.
Right.
But these challenges become even bigger as AI becomes more powerful.
They do. We need to have really thoughtful conversations about these implications and really develop those frameworks and guidelines to make sure that AI is being used responsibly.
And that's where the field of AI ethics comes in.
Exactly.
It's a fairly new field,
It is.
but it's getting a lot more attention.
Yeah, because we're having to really grapple with these consequences.
Right. So what are AI ethicists working on?
Well, they're trying to address things like fairness and bias, privacy, accountability, and the impact of AI on human rights and values.
So it's a very complex field.
It is.
And it's important to make sure we have a lot of different people contributing to the conversation.
Absolutely. AI needs to be developed and used in a way that benefits everyone and promotes a just society.
So as we wrap up this deep dive, I'm just struck by the sheer scale of this. It's a testament to human ingenuity and that drive to explore the unknown.
It's a really exciting time to be witnessing the birth of something that has the potential to completely change everything. But it's also a time for caution.
Right. We have to approach AI with wonder and optimism, but also with that awareness of the risks.
Yeah, we can't forget about those. And the future is not set in stone. We're shaping it with our choices.
Exactly. So the decisions we make today will have those lasting consequences. So let's work together to create a future where AI is a force for good.
A force for good, driving progress, empowering humanity, and creating a world where everyone has the opportunity to thrive.
Exactly. Thank you for joining us for this deep dive into the AI business ecosystem.
Yeah, we hope you enjoyed it.
We hope this has made you more curious.
And maybe inspired you to learn even more.
And as we move forward, let's all be mindful of the implications of this technology.
And work together to shape a future that benefits everyone.
Thanks for listening to Mythos AI. Stay tuned for more concise insights. And remember to hit the like button and subscribe for future episodes.